Alright, welcome back. In this video, we'll be the objective is to be able to add and subtract whole numbers. And so let's go ahead and get started. And as you can see here, I've kind of set up in the system of the Cornell notes. Actually, I guess I could also draw this line here and draw this line here. You guys know how to do that already, so I'm not going to this time I'm not going to do it exactly the same as what you will need to put on your paper. I have some of the key words here on this left side, but you will be responsible for listening and actually writing down these definitions. We're going to do the two main definitions that you need to know are the rational numbers and the real numbers. And I added imaginary numbers and irrational numbers just to help explain what those other terms mean. And so first, for real numbers, basically any number I think that you would think of or use in math anytime soon is going to be considered a real number. Fractions are real numbers, decimals are real numbers, even things like pi and numbers that square root of a prime number. Those are also considered real numbers. Basically, the main number that I could think of, or the typical example given that's not a real number, and that would be an imaginary number, and that would be something like the square root of a negative number, because we know the square root of positive 4 is 2, because 2 times 2 is 4. And so the square root of 4 would be 2. But you can't multiply 2 times 2 and get negative 4. And also, if you haven't studied this already, when you multiply negative 2 times negative 2, that also gives you a positive 4. So there's no two numbers that you can multiply together to get a negative. So under real numbers, it would be basically include all numbers except for the imaginary numbers, which would be the square root of a negative number. I think that would be a fine definition. If you wanted to include in real numbers, includes fractions, decimals, integers, that would be fine as well. Now, rational numbers are a little different. Rational numbers, they need to be able to be written as a fraction. Need to be able to be written as a fraction. So any fraction will be considered a rational number, and also included in that are, for example, I'll just say 1/2, and you know that the decimal for 1/2 is 0.5. Another example for a rational number that you can write as a fraction would be 1/3, and if we write 1/3 as a decimal, most of you guys know that's 0.3 repeating. Okay, so all numbers that can be written as fractions would be a rational number, and also all decimals that either stop, we usually call that terminate, 0.121. If it stops, that's also a rational number, because you can write that as a fraction. And any decimals that repeat 1.33333 or 0.27272727, those would be repeating decimals. Those would also be considered rational numbers. And there's a few irrational numbers. For example, the square root of a prime number would be an irrational number, because that decimal does not repeat and it goes on forever. And maybe one last example that you guys are familiar with is pi. Pi, sometimes we approximate that to 22/7, but it's not actually that fraction. Pi is a number that 3.14, and then it goes on, and it does not repeat, and it does not stop. So that's a little bit of vocabulary for you. And so now let's talk about adding whole numbers. And I know this is kind of review for some of you guys, but to add whole numbers, basically you want to line up all of the ones and the tens and the hundreds and sorry. And let's do maybe an example. If I have 257 plus 48. Well, we know that the 7 is in the ones spot, the 8 is in the one spot, so it's usually good to line these up vertically, and so I'll do that here, and I'll write 2, let's get some separation here, 2, 5, 7, and then since the 7 was in the one spot and the 8 is in the one spot, I'll put the 8 underneath the 7. The 4 is in the 10 spot. This 5 was in the 10 spot, so I'll put those. You'll notice they're lined up on the right-hand side here. And then I'll just go ahead and add those together. 7 plus 8 is 5. And we carry the, 15. We write 5, carry the 1. 5 plus 1 is 6. 6 plus 4 is 10, so we will write 0. And then again, carry the 1. Now we have 1 plus 2 is 3. And so let's estimate and see if that's approximately correct. We have approximately 250 plus approximately 50, and that gives us approximately 300, and I think we did it correctly there. Let's do one more. What if we have, I'll just write these now vertically for you. If we have 1,392 plus 465. And one thing that I want you to notice is that, I don't know if you can see this, I think you can. I'm using graph paper, and you guys are required to use graph paper as well, and so it's a good idea to have these all line up one number in each box when you do these. So let's see, 2 plus 5 is 7, 9 plus 6 is 15, so we'll write 5, carry the 1, 1 plus 3 is 4, 4 plus 4 is 8, and 1 plus nothing is 1,857. And so let's see if that's correct by just estimating. We have approximately 1,400 here, plus maybe 450, I guess, if we want to round that very easily. That's about 1,850. So I think we have the correct answer here. Okay, subtracting is the same way. Let's take, for example, if you have 683 minus 451. Again, I'm going to put, well, until we get into integers, we'll have the larger number first usually. So let's line these up, the 6, 8, 3, and the 1 was in the ones place. We'll put the 1 here and the 5 here and the 4 here. Draw the line and subtract. 3 minus 1 is 2. 8 minus 5 is 3. 6 minus 4 is 2. Let's estimate that about, we'll just do 680 maybe this time. 680 minus 450, that should be around 230. And we have 232, so it's probably correct. Let's do two more. Let's do 732 minus 694. Okay, let's try that one. Now here we have 2 minus 4, so we're going to have to borrow, if you remember how to borrow. This is 32, so we're going to make this, if you want to think of it this way, 2, and this is 12, so that's like 20 plus 12, it's kind of holding the spot. So we borrowed from the 3, and we'll write 2 here, and we'll add that tens spot to the 2 here to make 12. 12 minus 4 is 8. And now we have again 2 minus 9, so we're going to have to borrow again. We'll make this 6, and we'll add the 1 here. So we'll have 12 minus 9 is 3. 6 minus 6 is 0, so we don't really need to put that, I don't think. And we're left with 38. And so if you remember, our original was about 730, and we subtracted about 700, and we got about 30 or so. Just a rough approximation. And let's do one last one. 5,016 minus 397. So we have 6 minus 7. We will have to borrow. Now in this case, we have a 1 here, so we're going to hold the place with a 0 and put the 1 here. So we have 16 minus 7 is 9. Now we have 0 minus 9. So we're going to have to borrow from here, but there's nothing to borrow from here. So we will borrow again. This will be 4. That 1 that we took out of here will make this 10. Since we had to borrow, we'll change this to 9. Okay, and I know this is a little tricky, but we can practice more in class. And that 1 will come here. So 10 minus 9 is 1. 9 minus 3 is 6. And the 4 minus nothing will remain as 4. Let's see. If we remember, the original was about 5,000. We subtracted about 400, and we're left with approximately 4,600. So again, if you need extra help, we will do some more practice in class. But basically, to summarize this lesson, to add, can't see it too well. To add or subtract, whole numbers, I wrote line up the ones and the tens and the hundreds, etc. And add or subtract borrowing when necessary. I'll read that one more time for you. To add or subtract whole numbers, line up the ones, the tens, and the hundreds, etc., and add or subtract borrowing when necessary. And so I do hope that was clear for you guys. If you have any questions, please don't hesitate to ask in class. And that's it for today. Thanks for watching.